Hello everyone, my name is Ananth, yes, and I'm here to teach you all machine learning techniques. So before we go into machine learning, I want to tell you all what are the different uh, syllabus that we are going to go through. So obviously, there are going to be a set of 12 different videos, starting with Introduction to ML basics. Then you move on to more of supervised learning of regression and classification, then dimension reduction methods of PCA and LDA, and then moving on to Gaussian models, clustering algorithms for unsupervised learning, SVMs, SVRs, perceptron algorithm, and eventually a small peek into deep learning where you get introduced to neural networks, optimization functions, how they work, and what is regularization. So all of them come under neural networks. Let us start with the first lecture, which is Introduction to Machine Learning. So first, why are we all learning machine learning? I mean, I believe most of you all are going to be AI and DS students. But even if you're not, machine learning is going to be a very, very important part of things that you're going to be learning and applying in your real life as well, considering you're all computer science students. So first, artificial intelligence. What is artificial intelligence? Well, we all humans, we have natural intelligence. We understand things, we perceive things, we think, we make decisions based off what we perceive. So when we try to make a machine to mimic a human behavior, you get artificial intelligence. Now, a subset of artificial intelligence is machine learning, where your models can look at data, figure out certain patterns, and then make predictions. So it perceives patterns from the data you feed them, and then it gives you a prediction or makes a decision on it. And a smaller subset of machine learning comes deep learning, where it is effectively similar to ML, where it looks at data and makes decisions, but deep learning is meant for much more complex problems, larger data sets, is computationally very heavy, which is why you have neural networks and other things. And usually machine learning has a limit beyond which it cannot learn patterns. Deep learning breaks that limit and continues to learn. So all of this in the end does come into data science, where you learn from the data or the predictions to make decisions, may it be in the business world or any other use case. You get results from the data, which can be statistic, it can be scientific. Now, moving on to what was there before machine learning. Now you have all the AI, the ML, DL techniques, which are all complex, makes things much more easier. So what was there before this, and what problem does machine learning solve from what was there earlier? This is something that you have to know. So before machine learning, everything was based on rule-based knowledge. Like you have a condition, if yes, and if no, accordingly you go to the next step. There's multiple rules it follows, and whichever follows a particular rule, it is that. So that is how we used to make decisions. As you can see, the analogy is, it's like giving someone a detailed recipe, but they can only cook that one dish exactly as written. And limitation, obviously, I believe a lot of you would have thought of, is what if the rules are too complex? How do you write rules to identify a cat? I mean, you can say whiskers, it's white, it has a tail, and so on. But let's say I ask you to write a rule for a tomato. You can say it's a berry, it's red in color, and it's edible. But the problem is, the same analogy or the same rules also apply for a strawberry, which means you have to go even more further. As in, a tomato tastes different, a strawberry tastes sweet, and so on. So the rules have to be very specific for each and every use case, which is very tiresome and takes a lot of time. So basically, machine learning solves this problem if the rules are too complex. Now, what is machine learning? Well, by definition, machine learning is the ability of a computer to learn patterns from data and make predictions without being explicitly programmed. So what does this mean? It basically means as you feed data to the computer or to the model, it learns patterns on its own and it makes predictions without the user or a human giving it particular rules or instructions. So basically, let's say we give the data, the computer, a lot of examples, a lot of data, and it learns the patterns. It understands what encompasses what and makes decisions accordingly. Well, as we saw in the previous slide, if you had to make a dish or had to make a cake in a rule-based method, you could only make that one particular one. But here, let's say you give 1,000 different finished cakes, of which obviously some are good, some are bad. You can either give them data saying which ones are good, which ones are bad, that becomes supervised learning, or you can just leave it as such and ask it to figure out by itself, which is unsupervised learning, which we'll be looking in the next few slides. And then the machine itself figures out what is a good recipe or a good cake. So just based off the data, when the machine learns or understands to make a decision on its own, it is machine learning. Now moving on to the machine learning process. So obviously the first step is to get data. Let's say you're in a particular domain, may it be financial, may it be retail, or anything. So first you need data. Now you can't just give this raw, unfiltered data into a computer or to a model, because they're going to have missing values, they're going to have few errors, they're going to be of different data types, there are going to be a lot of anomalies in other parts of the data. So you have to obviously clean and prepare and manipulate the data so that it is useful for the model to understand the patterns properly. Which is where we come to the third step. We train the model. So you usually select a model depending on the data and depending on your use case, and you train it. And once you train the model, you obviously are going to test the model on some data, on some test data, which is unseen while training. Usually we use a 80-20 split, where while training, the model only looks at 80% of the data, and while testing, you test the model, you test the trained model on the remaining 20% of the data and see how accurate it is. And once this is done, you try to improve your model by looking at the test results. If you believe it is not sufficient enough and you can improve it, you can either improve it in the second step by cleaning and manipulating data much better, or even by changing your training hyperparameters, or even changing your model itself. So this is your machine learning process. Now, how do machines learn in machine learning? Just like humans, machines also learn in different ways. Let's say, first off, I give you a picture of a dog and a picture of a cat. And then I show you multiple pictures of different dogs and different cats on the screen and ask you to find out what is a dog and what is a cat. So this is effectively a supervised learning, where I am telling you what is what, and then I'm asking you to classify them. Next, let's say I only show you pictures of dogs and cats without telling you what is what before. But still, you yourself can find out what is a dog and what is a cat, because they're going to have different features. So without me telling you what is what, when you figure out that there are two different things, this is unsupervised learning, which means you are learning on your own without any input from me. So these are the two major types. After this, obviously, we have semi-supervised learning and also reinforcement learning, where there's an environment and reward policy through a feedback loop by which it learns. But throughout this course, we are only going to be learning more about supervised and unsupervised learning. Supervised learning. So as you can see in the image, we have the labeled data along with the labels. So both the data and the labels are fed into the machine learning model, and it learns the correlation based on your labels and accordingly finds patterns and makes predictions on the test data. So basically the algorithm learns from labeled data. Labeled data is obviously going to be right majority of the time, which is a major part of your pre-processing. So an analogy of supervised learning is, you have to think of it as you're studying for an exam with an answer key. You have your questions and you have an answers, and you learn what is the correct question and what is the correct answer accordingly. Now, where do we use this supervised learning in the real world? Here are a few examples. So initially we have email spam detection. Let's say I give the model thousands of 10,000s of emails and tell it what is spam and what is not spam. So accordingly it can figure out if there's any pattern or any particular wording because of which a particular email is spam and which is not spam. And accordingly it can find out when I give it new data or a new email whether it is a spammed email or not. And medical diagnosis, let's say you have your tumors, you have your cancers or any allergies. I can tell you whether I can tell the model, what is what, whether this is a picture of a tumor and this picture does not have a tumor, and I feed it multiple amounts of pictures. Again, it learns patterns from these pictures to find out which pictures have tumor, which pictures do not have a tumor, and accordingly it can make results. So most of this in the first two examples are yes or no based decisions. Now when we go to a house price prediction, it's not a yes or no decision, it's more of a numerical prediction. It can vary, it's dynamic. But still, even here, supervised learning works because it finds the correlations from the data you feed it, which can usually be the area where the house is, number of square feet, number of bedrooms, number of bathrooms, how well it's furnished, how old the house is. So based on all this, it itself finds a correlation to the selling price that you feed it as a label, and accordingly when you give an input of a new house with all the data that it was trained on or the features that it was trained on, it can accordingly predict the price of a new house as well. Unsupervised learning. Well, it's just the opposite of supervised learning. In supervised learning, you have the data and you have the labels telling you what particular parts of the data are right or wrong or what is what. Here, you do not give it any input at all. All you do to the model is to give it the data. And the algorithm itself learns from the data to find out what is what by finding out differences in the patterns. And accordingly, it separates or gives you decisions. So where do we use this unsupervised learning in the real world? First off, customer segmentation in marketing. So we give the input as customer purchasing history. So here clearly we do not know whether a particular person is a budget shopper or whether he keeps coming again and again and so on. But when you feed this huge amount of data filled with huge amount of people, your machine automatically is going to cluster or classify people to make differences between different types of shoppers, and accordingly we can make targeted marketing campaigns. Or in a retail store often products are arranged next to each other so that people who usually find one item are often looking for the other item as well, and they can find it easily when it's right next to them. So all these things are done through unsupervised learning. Next, moving on to recommendation engines. Let's say you watch a movie on your YouTube, on your Netflix. Yeah, you get your recommendations. So this is based off what other people watch, which is similar to what you have watched so far or in your history. So again, here there's no label data. All you give input is, I have watched these 15 videos in the past 5 days, and you watch, let's say, another similar 10 videos. So automatically tells you there's another person who has watched these 15 videos. So the other 5 videos may be relevant to you, and it shows up as a recommendation on yours. Accordingly, when we go to anomaly detection in cybersecurity, usually you have your normal network traffic and so on, but suddenly when you see a spike which is not from normal, you can obviously see it as an anomaly. The machine notices it's something deviating away from normal. Now it does not know what is normal and what is not normal. So accordingly, when something is going away from a particular understanding or a particular pattern that is identified, it can tell you that it's an anomaly and it could probably be a cyber attack. To give you an overall summary of supervised learning and unsupervised learning, supervised learning is basically where you give data with labels, and unsupervised learning does not have any labels. And in supervised learning, you know the outcomes and what you're looking for. In unsupervised learning, you expect the machine itself to find the patterns and tell you, hey, this is what I believe are similar. So you have your regression and classification types of problems in supervised, whereas unsupervised is more of clustering, grouping people together, finding how people or entities are related or making associations between them. And in the end, supervised learning gives your labels or predicted labels and predicts outcomes for new data, whereas unsupervised learning gives a cluster or a few association rules as output by finding the hidden patterns and useful insights from the large datasets. So, give you an overall overview, machine learning is split into supervised learning, unsupervised learning, and reinforcement learning. Supervised learning is further split into classification and regression based tasks, which have their own different types of models. Unsupervised learning has clustering based tasks, and the difference between supervised and unsupervised is supervised learning has labeled data, unsupervised learning has unlabeled data, and reinforcement learning, where the model takes actions in the environment and gets feedback from them through a reward mechanism, which we are not going to look through in the course of this lecture. So thank you all, and in the next lecture we'll be looking into a few basics of machine learning which you all must know in order to definitely understand the different models. And I'll see you in the next lecture. Thank you.